Okay, part 3 in the series, Am I Ready for Math 104? We have this question that involves x's and y's all intermingled together. This is called an implicit function. It cannot be written y as a function of x only. We're asked to take the derivative at that point, -2, 3. Anytime, then, what's going to happen is we're going to take this function, which is described by this equation, xy minus 2y squared equals x cubed y. It represents a curve. It might not be our literal sense of function passing the vertical line test, but we can still find the derivative of it. And what we have to use is called implicit differentiation. In implicit differentiation, what you do is you take the derivative of both sides, and what you have to be keenly aware of are terms that have both x and y in them. And so we have this term here, x times y, and on the other side of the equals we have this term there, x cubed times y. With those terms, what we want to make sure that we do is treat them as a product. Y is a separate function of x, although it can be written as some f of x. And so we treat x and y as like x and f of x and do the product rule. Treating x as the first function and y as the second function, we go to take the derivative of the first, multiply by the second, we put a plus sign, we take the first and multiply it by the derivative of the second, and we use the symbol dy dx. Or y prime if you want to use that. And that makes the derivative of that first term now be complete. On the second term, we have minus 2y squared. Its derivative is minus 4y for sure, but y is a separate function of x. It's like the chain rule taking effect here, and we have to multiply by dy dx. Anytime you go to take the derivative of a term with y in it, you have to multiply by dy dx. And then on the other side of the equals, we have this happening again, where we have this time the first function is x cubed, while the second function is y. I won't write this notation here, but we'll have the derivative of the first, which is 3x squared times y, and then we'll leave the x cubed alone and multiply by dy dx, y's derivative. Now, normally what you would do would be to get a formula for dy dx and then plug in, but it's better to plug in right now to replace all the variables with numbers. We're interested in this specific point when x is -2 and y is 3. So just plug that in. And then you'll be dealing just with numbers. What happens basically is this becomes an algebra question at this point. The calculus is over. We have basically y, which is 3. And then we have x times dy dx. That's going to be the guy that we're going to be seeking. Minus 12 times dy dx is equal to, we have a 3, a -2 who gets squared, and a 3. Then we have a -2 who gets cubed. Sorry, that's not right. Oh yeah, that is right. Yep, that is right. Sorry, doubting myself. -2 who gets cubed, and then a dy dx again. And so what we're looking at then is 3 minus 14 dy dx is equal to 36 minus 8 dy dx. We have a 3 times a 4 times a 3, or 9 times 4. So we get the 36. And then, yeah, we'll just maybe ship these over and get 6 dy dx. Ship these over, take away 36, and get a -33. And divide by 6. So isolate the dy dx term, and we'll find out then that dy dx is -33 over 6. You won't see that on the multiple choice. What we have to do is take out a factor of 3. And the answer is -11 over 2. he's going to take longer than normal. That's okay. Our function is x minus twice the sine of x, and we're asked about find an interval where the function is increasing. Increasing is where your first derivative is positive, greater than 0. The derivative of this function is 1 minus 2 cosine x. Let's first find where it's equal to 0 at. That means that 1 is twice the cosine of x, or the cosine of x is a half. Now we're interested in x is between 0 and 2 pi. Cosine takes on the value of a half twice in that interval. On the unit circle, cosine is a half in 2 places. This angle here is pi over 3, and this angle down here would be 5 pi over 3. And so that's going to chop up our interval. We start at 0, we end at 2 pi, and we have intermediate values of pi over 3 and 5 pi over 3. So that's how our interval is chopped up into now 3 pieces, and we're interested in the sine of the first derivative. If you plug an angle in that's between 0 and pi over 3, we want to know what sine is the derivative. The derivative is 1 minus twice the cosine of x. And if you plug something like pi over 4 or pi over 6 in, you're going to get a negative value. 1 minus twice the cosine of pi over 6 is 1 minus twice root 3 over 2. So that's 1 minus root 3, and that's a negative value. So you're negative, then you're 0. But then if you pick something that's in between pi over 3 and 5 pi over 3, a good value would be pi. These are test values. 1 minus twice the cosine of pi. Cosine of pi is negative 1, so that's 1 plus 2, or 3. So the derivative is positive there, everywhere in that interval. And then it flips back to negative again. 1 minus twice the cosine of 11 pi over 6. That'd be another 1 minus twice root 3 over 2. Yeah. Why did I use per? Yeah, that's right. And so that's another negative guy. So there we have it. You are increasing between pi over 3 and 5 pi over 3. Technically, you're not using. You shouldn't use square brackets here. You're not increasing on those values. Technically, you should be using parentheses. Letter A. Okay, this next function, talking about concavity, that's about the second derivative. Concave upward means the second derivative is positive. Well, the first derivative, we've seen this in the previous video. You take, maybe we haven't seen this version, but anyway, if you have a function who is the ln of another function, when you take the derivative of it, you do 1 over that function times the derivative of that function. So 1 over x squared plus 1 times the derivative of x squared plus 1, simplified to be 2x over x squared plus 1. But we need the second derivative of that, and so of the original function. And so we're going to take a derivative of this first derivative by doing the quotient rule. Taking x squared plus 1 and squaring it, taking x squared plus 1 and bringing it up, taking the derivative of 2x, putting a minus sign, leaving 2x alone, and multiplying by the derivative of the denominator, who happens to also be 2x. And what we'll be looking at after simplifying is 2x squared plus 2 minus 4x squared, all on top of x squared plus 1 quantity squared. That's what your second derivative is at any value of x. So it'll be simplified to be 2 minus 2x squared, putting these x squared terms together. And so factoring out the 2, what we get is 1 minus x squared on top of x squared plus 1 quantity squared. Not that that 2 goes away, the 2 is still there. And so there is your second derivative. Just like before, we want to know where it's equal to 0 at. So we can take our interval and chop it into pieces. It would have to be f double prime equals 0 would have to occur when 1 minus x squared equals 0. If that doesn't happen, also be a place where the denominators are in it, and the denominator is never 0. And so we have x squared is equal to 1, so plus or minus 1. So at -1 and at 1, it breaks up the interval. We know the second derivative is 0 at these places. And now we want to know the sign of the second derivative every place else. The denominator is always positive. It's a x squared plus 1 who's always positive, then something, and then that thing is squared. 2 is positive, so the changing sign occurs from looking at 1 minus x squared. If you put a test value of 0 in, you're going to get a positive value. But if you put a test value of 10 in, it's going to be negative. If you put a test value of -10 in, it's going to stay negative. So where's this guy concave upward? Between -1 and 1. Okay, great. Yeah, we should chop this video up. This is going to take some time. This is your classic related rates question. You have a ladder who is leaning against a wall, and then top of the ladder is sliding downward at a rate of 4 feet per second. How fast is the foot of the ladder being pulled away? Here's the ground. So that's going to cause that to go in that direction. And we want to know how fast. At the particular instance when the foot of the ladder is 8 feet from the wall. And so the ladder doesn't collapse. It stays as a 10-foot ladder. And so to solve this related rate question, in most cases the related rate questions get solved the following way. You need to draw a picture that represents the changing aspects of the problem. Where the ladder meets the wall is changing, and how far the ladder is away from the bottom of the ladder is away from the wall is changing. dy dt is how fast that it's moving down the wall, and dx dt is how fast it's moving away from the wall, on the ground. And our task is to find dy dx. And we do that by taking this and relating these variables to each other using the Pythagorean theorem. The fact that x squared plus y squared has to be 100, 10 squared. So you draw the changing picture, you get the equation, and then you take the derivative of that equation. We get 2x, but don't let it stay there. X is changing with time, so dx dt. Then we get 2y, but y is changing with time, so chain rule dy dt. And then 100's derivative is 0. And we have to plug the players in. We are trying to find dx dt, and apparently we're going to need the other three guys. We're going to need the x, the y, and the dy dt to find our guy. They tell us x. The foot of the there's a snapshot in time that we're interested in. The snapshot in time is when the foot of the ladder is 8 feet away from the wall, and this is a classic 3, 4, 5 triangle, right triangle, but everything's been doubled. And so we get 10, 8, and 6. So y would be equal to 6 when x is equal to 8, and they gave us dy dt. Be careful. They said it was 4 feet per second, but it's a negative value. Y is decreasing, so we have to enforce this. since y is decreasing. Okay, so we plug the players in. 2 times 8 times dx dt plus 2 times 6 times a negative 4 should be equal to 0. Or 16 dx dt is equal to 48. dx dt would be 3. Feet per second would be the unit. Okay, that's your classic related rates question. 2 tough topics in Math 103, the Introduction to Calculus, or Calculus 1 in other places, is the related rates and optimization. Okay, this one we might be able to do fast. We're already at 16 minutes for this video, sorry. The point of inflection is a place where your second derivative changes sign. And so if your first derivative, if your function is a nice polynomial x cubed minus x squared minus x plus 1, then your first derivative is going to be 3x squared minus 2x minus 1, and your second derivative is going to be 6x minus 2. I'm going to set that equal to 0, and we get 6x is equal to 2, or x is 1/3. But we have to check and make sure at 1/3 we need for that second derivative to change sign, and it does. This is a line. If you plug in something smaller than a third, it's going to be negative. But as soon as you plug in something larger than a third, it's going to be positive. Do a test value of 0 and 5, and you'll see that. So yes, you change sign at 1/3. X equals 1/3. That is the x coordinate. They don't want the y coordinate, they just want the x coordinate. And so 1/3 is the answer. Okay, that would be the end of part 3.